So if you remember on Tuesday, we just got through a little bit of maybe like halfway through 8.1. So we're going to pick up the rest of 8.1 today, and then we'll get into 8.2 and whatever we don't finish today, which will be probably most of it, we'll then roll over till next Tuesday of next week. So if you're keeping your mind on the schedule, that means not next week, but the week after we have test 4 due, which is our last exam. And that's going to be over chapter 7 and 8. I will be reviewing, I'm trying to, I guess I don't have my schedule in front of me. So I will finish content on Tuesday of next week. Thursday, I will review, which means your exam will release Thursday, and then you will have the exam due the following week. And I don't have that date in front of me, but obviously come Tuesday, I will have that information. And then the following week, because we have 2 weeks of school left, 2 weeks of regular school left after this week, which is nuts to even say out loud, right? Because this is week 13. If we don't count spring break, and then we have week 14 and 15, which are normal class, and then finals week, which we will not meet during, and you will do your final exam during that week at home, like you have with everything else. So next week is week 14. I will teach half the week, I will review half the week, and then week 15, I will spend reviewing both days that week for the final. So we'll cover, you know, all the chapters because it's a cumulative final. So it's going to be all the things. So keep that in mind, right? Just in terms of what's going on. So we were like right at the end of new material, which is good because it gives us lots of time to review for the exam and for the final. Anyways, any questions for me before I get going back into everything? Okay, so let me share my screen with you. So let's just do a really quick review of what we talked about, okay? So if you remember our powers of 10, 10 to the third equals 1,000, 10 to the second equals 100, 10 to the first equals 10, 10 to the 0 is 1, 10 to the negative first is 0.1, 10 to the negative second is 0.01, and 10 to the negative third is 0.001. Now remember with logs are taking, we're asking ourselves, it's undoing this, right? So it's saying, okay, to what power do I need to raise a value to? So if I did log of 1,000, the answer would be 3 because 1,000 is equal to 10 to the third. Log of 100 would be 2 because again, 10 to the second is 100. Log of 10 is equal to 1 because 10 to the first is 10. Log of 1 is equal to 0 because 10 to the 0 power equals 1. Log of 0.1 equals -1, again, because 10 to the negative first is what equals 0.1. Log of 0.01 is equal to -2, and log of 0.001 equals -3. So in our problems that we have here, we've got log of 124, and I want to approximate the answer to that. So I want you to think about what number could this answer be between, and then I want you to actually use your calculator and find that answer. So first send me your approximation. And then your actual answer. Okay, so let me explain what I'm asking. I think I'm not being very clear on what I'm talking about. So when I look at log of 124, the question we're asking ourselves is 10 to what power equals 124? Well, 10 to the second is equal to 100, and 10 to the third is equal to 1,000. So the number 124 is somewhere in that range between 100 and 1,000. Therefore, it's got to be between 2 and 3, the answer. Now, because 124 is closer to 100, we would assume that our answer is closer to 2. So when we go and put this into our calculator, one second, my calculator is being weird. I'm using the Desmos graphing calculator. So I'm going to do log and then parenthesis, and then we can do 124. And again, the reason I'm using this instead of like the graphing calculator is because this is free and I know not everybody has a graphing calculator. So when I put log 124 into my calculator, I get 2.0934, blah, blah, blah. And so it's approximately equal to 2.09, which again, we can see, we said that it was closer to 2 because 10 squared is equal to 100. So now thinking about number 2, I've got log of 0.12. So remember, logs are just inverses of powers of 10. So again, what we're asking ourselves is 10 to what power equals 0.12. So again, looking at our tables on the side, right? Look at over here. How would we approximate that answer? What would we say it's going to be close to? Sorry, I forgot that I wasn't showing you that table again. So again, what I want you to think about where 0.12 lands in that list of powers of 10, right? And then looking at the exponents, where would it be close to? Okay, so especially when we're dealing with the small numbers, this can be a little harder to wrap our brain around, okay? So let's think of a number line. And looking at our powers of 10 here, I've got 1, and then next to it, I've got then 0.1, and then way down here, I would have 0.01, right? As we get closer to 0, move this to the left so I can move it to the right, excuse me. And we just kept going. Eventually we'd hit 0, right? Now this isn't showing us necessarily to scale, but I just want you to think about where these numbers live. So 1 represents 10 to the 0, and 0.1 is 10 to the negative first. So 0.12 is like right here, right? So 0.12 lives between 10 to the 0 and 10 to the negative first, right? It's closer to the -1 range because of the fact that 0.12 is close to 0.1. So we would say that it's going to be between 0 and -1, but closer to -1. So if we put this into our calculator, we do log of 0.12, we get -0.9208. And -0.9208 is very close to -1, right? And so we're seeing how those two correlate to each other. So number 3 says log of 2/3. So if you were to put this into your calculator, you're going to do log of 2/3, 2 divided by 3, having that in parentheses. Now, remember what we're saying is 10 to what power equals 2/3? So remember 2/3 is equal to 0.6 repeating, right? So I think about in the continuum between 0.1 and 1, okay, this is where we want to put that number first in that continuum between those. 0.6 repeating is close to 1. So log of 0.6 repeating is going to be close to 0. Why? It's because the log of 1 equals 0 because 10 to the 0 power equals 1. They are related to each other. They're inverses of one another, right? So because 0.6 repeating is close to 1, we are going to say that the answer must be close to the log of 1. And when we put this into our calculator, we get negative 0.1761. Now, your homework is not going to ask you to approximate these. The whole reason why I'm having us talk about the approximation is so that you can gauge for yourself the reasonableness of your answer when you put it into your calculator to figure out, oh, what, shoot, did I maybe like put in a wrong number? Did I make a mistake? That's the only reason why I'm having us approximate this, okay? So on your homework, it's going to ask you to do these, and what they're expecting you to do is literally just type log of 2/3 into your calculator, spit out the answer, and report it as it is, okay? I'm just having us look at the approximations, so again, we can gauge the reasonableness of these answers. So if we take the log of something, we have to be able to undo this. Okay, so that's what the next page has to do with. Just like we need to undo exponential equations to solve for the exponent, sometimes we need to undo logarithmic equations to solve for the variable. Your book calls this process finding the anti-logarithm. And here's what it looks like. If I have log of x equals 5, I want you to remember that there is a little tiny 10 there because log is base 10. So to solve for this, I'm going to rewrite this as log base 10 of x equals 5, which we then use and say 10 to the 5th equals x. And that is the relationship between those. That's how I'm going to undo it. And if we calculate that out, we get 100,000 equals x. Because remember, this question is saying log of x equals 5 says 10 to the 5th power equals what? That is the relationship between those two things. Okay. So thinking about what we did in the example, I want you to try number 1. So again, we're going to remind ourselves there's a little tiny 10 there that we can't see, right? And so log base 10 of x equals 3. To undo this, I'm going to say 10 to the 3rd equals x. And if you want to finish calculating this, you can say 1,000 equals x. Okay, we're ignoring the second column. We're just going to focus on number 2. So it says log of x equals negative 0.02. Okay, so log of x equals 10 equals negative 0.02. So to undo this, we have to use 10 because 10 and log are opposites of each other. So again, rewriting it, we're going to say log base 10 of x equals negative 0.02. Now, because the negative number is on the right-hand side of the equal sign, it's away from the log, we're okay. Remember, we can't take the log of a negative number, but the log of something can equal a negative number. So we're going to do 10 to the negative 0.02 equals x. And if we put this into our calculator, we get x equals 0.95499, and it keeps going. So we're going to say that x is approximately equal to 0.955. So then we've got some new writing here. This is log to the negative first of 4 equals x. All this means is 10 to the 4th. That's all they're saying there, because it's the inverse of a log, and therefore it's undoing that. So how they got there would have been log of x equals 4, and so log to the negative first says undo that, and we would say that it's 10 to the 4th. Okay. So using that idea, what would we write for number 4? So again, log to the negative first. All that's telling us is do 10 to, and then we put that number in for the exponent. And you can leave it as 10 to the 1.25, or you can actually calculate that, giving us 17.7827 or 17.78 is what I'm going to go with. And then another way that you will see it represented is anti-log. Again, much like log to the negative first and anti-log, they mean the same thing. So anti-log of 6 equals x just means 10 to the 6th equals x. So you're just taking this anti-log part, thinking 10 to that value. So then what would we write for number 6? So again, anti-log just means undoing. If I were to relate this to what we were doing, say in number 1 and 2, how do these relate to each other? So the solution to this is 10 to the negative 1.3 equals x. If I were to write this using logs, I would say log of x equals negative 1.3. So to undo this, I would have that little power of 10 down here. I would raise it to the negative 1.3 and it's equal to x. So that's sort of showing how anti-log notation matches our normal log notation. Again, all we want to know is, can you take that anti-log piece and think, oh, that means 10 to the exponent of whatever the number is there, okay? So questions about those before we move forward? So anti-log is undoing logs. So if I had, let's see, how can I write these together? Let's say I had log of x equals 2. Then if I took the anti-log, that would say that anti-log 2 equals x, which means I would write 10 to the second equals x. So that's how I would go from the first log notation into anti-log. So if we think about our table from the previous page, let's look at this. So taking logs of values to get the whole ones, I would use anti-log to go the opposite direction to get back to the actual exponent part, okay? So the whole reason we're looking at these is so that we can talk about the pH scale. And so before we can talk about pH scale, we have to get into hydrogen ions and hydroxide ions. So we have ionic solutions. So we have acids. Oh, geez. Glad that was on recording. Acids. Good thing we're all in the college level and I'm not teaching 8th grade like I did at the beginning of my career. That would be fun. So acids, add the D in there, they contribute protons of H+, and H+ is hydrogen. And so when we look at these acids, a strong acid has a larger amount of hydrogen ions in it. A weak acid has a lower amount, right? So in our image, we can see there's 1, 2, 3, 4, 5, 6 hydrogen ions in that HCl versus just 2 in the HF. So OH negative means hydroxide. And so bases have a larger amount of hydroxide ions than hydrogen ions. So the two extremes are still very caustic. I can't say acidic because we are already associating acidic with acids, but they will both eat through materials. They're very caustic. So we have basic or alkaline solutions are one end, and acidic solutions are on the other end. Salts contribute neither. The term disassociate means to separate their bonds. And then strong acids and bases disassociate completely. And then neutral is an equal number of hydrogen ions and hydroxide ions. So moles, not like the little things that are in the ground. So a mole contains 6.02 times 10 to the negative 23rd atoms or molecules. 6.02 times 10 to the negative 10 to the 23rd is known as Avogadro's number. And then you know how we have like Pi Day, March 14th, right? So October 23rd is known as Mole Day because the 1023. Less popular. And then the molarity of or concentration, which is measured in M, is we take the number of moles and we divide by the number of liters in a solution. So number one says given 1.806 times 10 to the 24th, molecules of HCl, how many moles do you have? So again, to calculate the molarity, we're going to take the number of molecules and we're going to divide by how many moles or how many molecules make up 1 mole. So we're going to divide it by 6.02 times 10 to the 23rd. And remember, with our work with powers of 10, we can divide these problems up into 2 pieces. So I have 1.806 over 6.02 times 10 to the 24th over 10 to the 23rd, right? We talked about scientific notation for a reason. It was coming back. So 1.806 divided by 6.02 gives us 0.3. And that's times, and you have 10 to the 24th over 10 to the 23rd. So all but 1 power of 10 cancels. So it's going to be times 10, which reduces to 3 moles. So again, to calculate the number of moles, you're taking the number of molecules they give you and dividing by the amount of molecules that are in 1 mole in order to calculate that. So thinking about what we did in number 1, I want you to try number 2. So number 2 says given 1.204 times 10 to the 23rd molecules of HNO3, how many moles do you have? Now, as we all know, I am not a chemistry teacher. I can help you do the math, but to actually talk about what these drugs are and what makes, or, you know, what these solutions are, what they're made up of, I'm going to be honest with you, I don't know. But I understand for the molecules and how we calculate the number of moles. So we're going to take what we have, 1.204 times 10 to the 23rd, and we're going to divide it by 6.02 times 10 to the 23rd. Again, we can break this up into 1.204 over 6.02 times 10 to the 23rd over 10 to the 23rd. 10 to the 23rd over 10 to the 23rd, those cancel. So 1.02, or excuse me, 1.204 divided by 6.02 gives us 0.2, and that would be 0.2 times 1, which is just 0.2 moles. Or not M. You want to actually write because M represents molarity. And so we're actually talking about moles. So we want to make sure we use the right notation. So speaking of molarity, let's calculate it. Looking at the next page, it says given 3 moles of HCl in 1.25 liters of water, find the molarity. So remember, molarity, to calculate that, we're taking the number of moles and dividing it by the number of liters. So if you were to be given a problem that had its the amount of liquid listed in milliliters, you would want to first convert that to liters, because again, we need the liters in the denominator. So for this one, we're going to do 3 moles over 1.5. So this is 3 moles over 1.5 liters, which gives us 2 M. So it has a molarity of 2. And again, the big M just means moles per liter. Okay. So try number 4. Number 4 says given 0.2 moles of HNO3 and 0.8 liters of water, find the molarity. Okay, so I'm going to take 0.2 moles. I'm going to divide it by 0.8 liters of water, which gives us 0.25 moles per liter, or 0.25 M, right? And we do need to use the capital M because the lowercase m is shorthand for meters. And so we need that capital M to represent the moles per liter. So talking about concentrations, strong acid and bases dissociate 100% in water. So the concentration of H plus or OH negative is the same as the molarity. Weak acids and bases dissociate a specified percentage in water. So the concentration of H positive or OH negative is the specified percentage of the molarity. So the relationship also between H plus and OH negative is that when I multiply them, they're equal to 1 times 10 to the negative 14th. So number 1 says given 0.4 moles per liter solution of a weak base that dissociates 5%, what is OH negative? So OH negative is going to be taking our molarity, 0.4, and multiplying it by its percentage as a decimal number, right? 5% equals 0.05. So when I multiply these together, I get 0.02. Therefore, OH negative is equal to 0.02 moles per liter. So number 2 says a weak acid has a hydrogen concentration What is the hydrogen concentration in 0.25 moles per liter solution that is 20% disassociated? So I want you to think about what we did in number 1 and apply that to number 2. So to come up with the hydrogen concentration, we're going to say it's equal to the concentration to begin with, 0.25, times the dissociation percentage, or 0.2. So when we multiply these together, we get 0.05 moles per liter. So number 3 says with a strong acid, remember the term strong acid means that it's 100% disassociated. What is the hydrogen concentration, or H+, in a 2 mole per liter solution? Think about what the 100% means. Let me expand upwards just so you can see what it says in that box again. So as it says, strong acids and bases dissociate 100% in water. So the concentration is the same as the molarity. So what is our concentration? Because it's 100% disassociated, it's going to be 2M. Again, if you wanted to use the math to represent it, we could think of H+ as being 1 times 2M, right? Because 1 is your percentage, meaning 1 equals 100%. So you could still get there by doing the process of taking the percentage of the concentration. Okay. So the next problem we're going to use is this fact right here. So I just want to point that out before I go to the next page. So it says find the concentration of OH negative given a hydrogen concentration of 0.4. So the hydrogen concentration means that we have H+ equal to 0.4. So the relationship between OH negative and H positive is OH negative times H positive equals 10, or excuse me, 1 times 10 to the negative 14th. You could write just 10 to the negative 14th as well. That's fine. So if we want to solve for OH negative, that means we need to plug 0.4 in for H positive. And we then need to divide both sides by 0.4. So in order to solve this, we would plug this into our calculator. So if you're thinking about, well, how do I plug that in? If we look at Desmos, we can do as our numerator 1 times 10 to the, and to get it, do you see how it popped up? I used that caret key. So I did shift and then 6 to get that little arrow thing that we do, the negative 14th, end parenthesis, divided by 0.4. And you can see that that gives us 2.5 times 10 to the negative 14th. So we have more practice problems. We're going to skip number 1 because I accidentally repeated it. So to think about number 2, it says, what is the molarity of 4 moles of KOH added to 0.5 liters of water? You're not seeing the thing. Hold on. Let me share it again with you. There you go. So my one cat is getting older, and I think he's just starting to like randomly scream around the house for no apparent reason. So he was back in the hallway just screaming as if like he was dying. I called him out to me and he's acting fine now. I don't know what's going on with him. So molarity, remember, we're taking our moles and dividing it by liters. So we're going to take 4 moles and we're going to divide it by 0.5 liters, which gives us 8 for our molarity. Okay, so number 3 says an aqueous solution has a hydroxyl concentration of, or OH negative, of 0.00015 moles per liter. Find the concentration of hydrogen ions in this solution. So I'm going to show you, zoom out, because I want you to use the method that we did in number 4 and apply it to number 3. So remember, for this one, we're using the fact that OH negative times H positive equals 10 to the negative 14th, or 1 times 10 to the negative 14th, right? So if we plug in what we have 0.00015 is OH negative times H positive equals 10 to the negative 14th. So to solve for this, we're going to divide both sides by 0.0015. Which gives us 6.6 repeating times 10 to the negative 11th. So we can round that to 6.67 times 10 to the negative 11th. When you're plugging into your calculator, make sure you're being careful of putting that 10 to the negative 14th as your entire numerator, or 1 times 10 to the negative 14th. So again, if you look at our last calculation, instead of putting 0.4 down here, I'm going to put 0.00015, and you can see how that calculates out. Again, it's just making sure that you are typing it in completely. The reason I like Desmos is that you can see it represented as you actually are typing it. And again, you can go back and just click on something if you're like, oh shoot, I put that in wrong. You can click on the specific thing and fix it, and then recalculate it, or it will automatically recalculate. So if instead of, let's say you put in 0.0015, that's going to give you 10 to the negative 12. And you go, oh wait, shoot, I needed to have 3 zeros. I can just click right here between the 0 and the 1 and add another 0. And you can see that it automatically adjusts for me to that 10 to the negative 11th. Okay. All right, so the last one we're going to do is number 4. That says a solution of 0.3, and this is not N, acid is known to be 75% ionized, and ionized just means disassociated. Find H plus, or the hydrogen ion concentration. So again, all we're doing here when we talk about disassociation is we're taking the percentage and we're multiplying it by the concentration. So we're going to take 0.75 times 0.3, which gives us 0.225 moles per liter. Okay, so up to this point, everything that I did that wasn't the log stuff was finishing up 8.1. So this has all been 8.2, and I'm going to stop us there before we get into pH, and I'm going to have us cover pH on what's that day? Tuesday, when we come back together. So let me pull up. We do have a homework assignment for 8.2. So 8.2, I want you to do numbers 1 through, well, here, let me just share it instead of saying this out loud. That's not going to help us at all. So you can see here, it's due April 29th. We've got page 244, numbers 1 through 15 odd. And 8.1, in case you hadn't looked at that yet, is due April 26th. It's page 242, numbers 3 through 39, every third problem. So we've got those 2 homework assignments coming up that will be due. So, but I'm going to wait and cover 8.3 on Tuesday. We meet up again after the weekend. So, any questions for me before we go? Yes, no, maybe so. All right, everyone. Well, I hope you have a good weekend. Quizzes, I am working on grading them once I get done, so they will be graded this afternoon / this evening. So later today. So they shall be graded later today. Any other questions? Are you hearing Frank in the background screaming? Is it coming through? Oh my gosh. Oh, I'm again working from my dining room because he has a fit when I'm in my office with the door closed, and clearly it doesn't matter. He's still gonna have a fit no matter what. So anyways, everyone, I hope you have a good weekend, and I will see you next week, okay? Have a good one, everyone.